Hey, have you heard about LatentSync? It's this new framework that's really changing the game in lip sync technology.
LatentSync? That rings a bell. What's so special about it?
Well, it's an end-to-end lip sync framework based on audio-conditioned latent diffusion models. And the cool part is, it doesn't rely on any intermediate motion representations like previous methods do.
Wait, so it's different from the pixel space diffusion approaches we've seen before?
Exactly. Instead of working in pixel space or using a two-stage process, it leverages the power of stable diffusion to directly model complex audio-visual correlations. Right. It's like they're tapping straight into the source, you know?
That's fascinating, but how does that improve the lip sync quality?
So, one big issue with previous methods was the inferior temporal consistency.
Yeah.
The diffusion process across different frames could be inconsistent, leading to jittery visuals.
So you get those awkward mismatches between the audio and the lip movements?
Exactly. To tackle that, they introduced something called temporal representation alignment, or TREPA. It enhances temporal consistency while preserving lip sync accuracy.
TREPA? How does that work exactly?
Well, TREPA uses temporal representations extracted by large-scale self-supervised video models to align the generated frames with the ground truth frames. It ensures each frame flows smoothly into the next, reducing those inconsistencies.
That's pretty clever. So they're using self-supervised models to get better temporal alignment?
Yeah, exactly. And what's really cool is they use Whisper to convert MEL spectrograms into audio embeddings.
Whisper? Isn't that OpenAI's speech recognition model?
Yeah. They integrate these audio embeddings into the UNet via cross-attention layers. It provides rich audio context for the model to generate accurate lip movements.
So the model gets a better understanding of the audio features?
Precisely. And they combine the reference and masked frames by channel-wise concatenation with the noise latents as input to the UNet.
That sounds complex. But I guess it allows the model to consider both the visual and audio cues simultaneously?
Exactly. It's like giving the model all the puzzle pieces it needs.
Yeah.
And during training, they use a one-step method to get estimated clean latents from the predicted noises, which are then decoded to obtain the estimated clean frames.
That's efficient. But what about the losses they use during training?
They incorporate TREPA, LPIPs, and SyncNet losses in the pixel space. LPIPs helps with perceptual image quality, while SyncNet loss ensures the audio and visual components are synchronized.
Comprehensive approach. But I'm curious, does relying on stable diffusion make the process more resource-intensive?
Well, using diffusion models like stable diffusion does require significant computational power.
Right.
Training and inference might be heavy, but the results are worth it.
I see. Do they provide any pre-trained models or tools for others to use?
Yes, they do. They've open-sourced the code and provided checkpoints on GitHub. It's great for the community to build upon.
That's fantastic. Open source contributions really help accelerate advancements.
Definitely. They also shared a detailed data processing pipeline.
Oh? What's involved in their data processing?
So they start by removing broken video files and resampling videos to 25 FPS and audio to 16,000 Hz. Then they use scene detection to split videos into shorter segments.
Makes sense. Shorter segments are easier to manage and process.
Exactly. They also remove videos where the face is smaller than 256 x 2156 pixels, or if there's more than one face.
So they focus on high-quality, single-face videos for better accuracy?
Yes, precisely. They perform affine transformations based on facial landmarks to align the faces and resize to 256 x 2156.
That's thorough. Do they filter out low-quality frames as well?
Absolutely. They remove videos with sync confidence scores lower than 3, and adjust audio-visual offsets to 0.
Right.
They also use image quality assessments to filter out poorly scored images.
Quality over quantity, I guess. But isn't there a risk of losing diverse data?
Well, it's a trade-off. High-quality data ensures better model performance, but you might lose some variability.
True. So how does their training process handle overfitting?
They leverage large datasets like VoxCeleb2 and incorporate various loss functions to generalize well. Plus, using self-supervised models helps in learning robust features.
That's reassuring. But do you think this approach is scalable for real-world applications?
It's promising, but the computational demands might be a barrier for some.
Yeah.
However, as hardware evolves, it could become more accessible.
I hope so. The potential applications are exciting.
Definitely. From virtual avatars to dubbing and gaming, the possibilities are vast.
Speaking of dubbing, this could revolutionize how films are localized.
Exactly. Imagine perfectly synced lip movements in different languages. It would
Yeah.
enhance the viewing experience significantly.
But with great power comes great responsibility, right? What about ethical concerns?
Absolutely. There's always the risk of misuse, like creating deepfakes.
Right.
It's essential to have safeguards and ethical guidelines in place.
Agreed. Developers and users need to be aware of the implications.
For sure. Responsible innovation is key.
By the way, do they mention anything about inference speed? Can it be used in real-time applications?
Currently, real-time might be a stretch due to the computational load of diffusion models. But with optimizations and hardware advancements, it's a possibility for the future.
That's encouraging. Technology evolves rapidly after all.
Exactly. And the open source nature of the project means the community can contribute to improvements.
Collaboration often leads to breakthroughs. It's an exciting time for AI and video synthesis.
Couldn't agree more. I'm really looking forward to seeing how LatentSync develops.
Same here. Maybe we'll soon have virtual meetings with perfectly lip-synced avatars.
That would be amazing. It's
Yeah.
fascinating to think about where this technology will take us.
For sure. Well, thanks for breaking all this down. Learned a lot today.
Anytime. Always happy to chat about the latest tech.
Let's keep an eye on this project and catch up again soon.
Definitely. Looking forward to our next discussion.